Dear friends, good morning. In the last session, we have seen the difference between power diode and power bipolar junction transistor. This today's session, we are going to learn about what are the difference between NPN and PNP power bipolar junction transistor based on the analysis of the category of structure, current flow, biasing, operation, circuit symbols and the applications. Let us see first the structure wise. The NPN bipolar junction transistor, the thin layer is P layer. At the same since the P layer is sandwiched between these two N layer. So that P layer is thin layer. But in the PNP transistor, N layer is the thin layer as the N layer sandwiched between the two P layers. Then in this NPN transistor, emitter will be connected to N layer, base terminal will connected to P layer and collector will be connected to N layer. At the same time, in the PNP bipolar junction transistor, emitter will be connected to P layer, base is connected to N layer and collector is connected to P layer. As far as the current flow is concerned, base is provided to give positive signal, for example with respect to emitter. For example, in this NPN transistor, base is connected to the P layer. Therefore, in order to make the junction forward bias, P layer is base is connected to the positive voltage. Then electron flow will happen in this NPN transistor. In the last time we have seen the construction and working of NPN transistor. If you have any doubts, kindly refer those. Go to the playlist of this channel and see the power electronics playlist. Under that you can go through each topic. So this in NPN bipolar junction transistor, electron is flows from emitter to collector. So the conventional current flow will take from collector to emitter. That means the current will flow in the opposite direction of electron flow. Therefore, in NPN transistor, base is connected to the positive. So the electron will flow from emitter to collector. Therefore, current flow will take from collector to emitter during on state. At the same time, in PNP transistor, base is N layer is connected to the base terminal. Therefore, we have to give negative voltage so that the junction will be forward bias. So in the PNP transistor, negative voltage we have to give. So that negative voltage with respect to that, the current will be given to the base. Then in this PNP transistor, holes will flow from emitter to collector, not electron. So that since the PNP transistor, P layer is having highly hole, majority carriers are holes. So the holes will flows from emitter to collector. So the current flow also the same direction, emitter to collector during on state. Then biasing. In the NPN bipolar junction transistor required positive voltage at the base for forward biasing. Already we know positive voltage. At the same time, PNP transistor, negative voltage at the base of forward biasing. Then second one, typically this NPN transistor used when the loads need to be connected to the collector and ground on the emitter side. At the same time, in the PNP transistor, load will be connected to the emitter, with the collector will be connected to the ground or the negative voltage. So that is just a difference between for the biasing of NPN and PNP transistor. Then next one, operation wise, the NPN transistor majority charge carriers are electrons. Already we know NPN is having highly doped electrons. So the majority carriers are charge carriers are electrons. At the same time, PNP transistor majority charge carriers are holes. Then NPN transistor generally preferred for high speed switching applications. Why high speed switching application? Because the electrons will have high mobility, so that when compared with holes, electrons will move fast. So the fast operation will happen in the NPN transistor. Already I told you, electrons are the charge carriers. So in the NPN transistor, so as the majority carriers are the electrons, so as the electrons mobility is so fast, so we can use for high switching speed operations, we can use the NPN transistor. At the same time, in the PNP transistor, they are used to when positive voltage need to be controlled, and wherever PNP configuration is required, suitable for the circuit design. For that purpose only PNP transistor will be used. So normally, at the nutshell, we can say the NPN transistor is majorly we will use as the mobility of the electrons are good, and also so that it is having fast acting, so that it will be used for high switching speed applications. Then circuit symbols, already we have studied the circuit symbols. Arrow mark on the emitter points outwards, away from the base. We can see away from the base, that arrow mark will be there. At the same time, PNP transistor arrow mark will be towards the base. Then that means why this arrow mark is changing in this NPN transistor away from the base? It indicates the current is flowing from current direction will be conventional current flow. That means from collector to emitter. At the same time, PNP transistor indicates the direction of conventional current flow from emitter to collector. Already we have seen NPN transistor, electrons are moving emitter to collector, therefore current is flowing from collector to emitter. In PNP transistor, holes are moving from emitter to collector, therefore current is also moving in the same direction, emitter to collector. Then applications are, normally these NPN transistors are widely used in digital circuits, amplifiers and switching devices. So similarly, in the PNP transistor, it will be used the situations where positive voltages are need to be switched or amplified. For that time we will use that. Normally NPN transistor is preferable. Then this NPN bipolar junction transistor commonly used in negative grounded system. In this PNP transistor oftenly used in positive grounded system. Okay, so due to the mobility of the electrons, normally many cases as the switching speed is also good, NPN transistors are preferable. So with this we can conclude the difference between NPN bipolar junction transistor and PNP bipolar junction transistor. Next session we are going to learn about the construction of the working of the MOSFET. Please subscribe this channel. Wish you all the best. Thank you.